Okay, these are problems 13, 14, and 15 from section 1.5. I got requests to do these ones, so we'll do these ones. Basically, all these are two-step proofs. This first one asks you to prove that y is the midpoint of xz, given that xy and yz are congruent. So the first step is always write down what's given. So your first step, what is given is that xy and yz are congruent. I'll mark that in the picture too, just to show me what I have. I want to prove y is the midpoint. Well, I'm just one step away. This is a two-step proof. So I know that y is the midpoint of xz, and the reason this is true is really the only thing you really need to figure out here. So why is y the midpoint of xz, given that xy and yz are congruent? So you want to say, if a point divides a segment into congruent segments, then it's a midpoint. And that's really all that you got here, because if y divides xz into two congruent segments, xy and yz, then that point y is a midpoint, and that's the answer to 13. So that would be what it looks like, and if you check the answers, it will look similar. Maybe not exact, but anything along those lines should give you enough points for these problems. So that was 13. Here's 14. Now you're given that three angles are congruent. You're given AEB, BEC, and CED are congruent. So because you know all these angles are congruent, the next, what you're trying to prove is that if EB and EC trisect angle AED, and this is basically like the definition of trisect. So I know this again is a two-step proof. So EB and EC trisect angle AED because, and now it's, again, this is the part that you got to concentrate on. What is the perfect reason for this to be true? The perfect reason is if two rays, which EB and EC are, if two rays cut an angle into three congruent angles, then they trisect the angle. So I'll just say, then they trisect. So basically what you got is that. You got two rays, EB and EC, cutting an angle into three congruent angles. So if three congruent angles are created by two rays, then those two rays are trisectors. So you see the if comes from here, and then the then comes from here. So if three congruent angles are created by two rays, then those two rays are trisectors. Okay, the last problem from this little group is 15. And this one gives you angle 1 and angle 2 are congruent, and you want to prove HK bisects angle FHJ. So again, it's a two-step proof. The first step, as always, has been the given. So statement 1 goes to the reason 1. So should be that. So that's given. Step 2 is, like I said, in a two-step proof is what you're trying to prove. So HK bisects FHJ. And this again is a lot like the last one. If two angles are congruent, so if a ray cuts an angle into two congruent angles, then the ray bisects. Okay, basically bisects that angle, and that's the perfect answer to that one. So I hope this helps. That was problems 13, 14, and 15 from section 1.5.